Okay, let's look at our first problem. I'm going to get it set up and then we'll go to the calculator so that you can see how to enter everything. Because we spent time with the formulas and because we spent time kind of going through the theory, I'm going to cut to the chase on this one and just get to the calculator part as far as getting the confidence interval. So this first example, it says a study of the ages of motorcyclists killed in crashes involves the random selection of 150 drivers with a mean of 37.1 years. If S equals 12 years, and then here's where the question is, construct a 99% confidence interval estimate of the mean age of all motorcyclists killed in crashes. And then it has a question here. It says, if the confidence interval estimate or limits do not include ages below 20, does that mean that motorcyclists under the age of 20 rarely die in crashes? What you want to do first is get the interval. After you have the interval, use the interval to answer the question. Okay, and really that's the point of our statistics. We're analyzing some data, we're coming up with a conclusion, and then we want to say, well, what does that mean? So we're making some sort of decision based on those numbers. Okay, so when I see this as a confidence interval for a mean, that tells me it's going to be a T-interval. Excuse me. If it had been a proportion, we would have used a 1 prop C interval. So looking at this word and knowing, am I talking about a mean? Am I talking about a proportion or a percent? That's going to help you determine the calculator function. And that's probably the hardest part of these. When sometimes students think, well, you know, that's hard figuring out the right formula. Well, figuring out the right formula, that's what you're doing when you're choosing the calculator. Which function, which formula. So we're going to input these values into our calculator to get our interval. So let me switch over to the calculator. So here's my calculator. I'm going to clear out, let me get my spotlight here. I'm going to clear out what's in here. And for this problem, we're doing a T-interval. We already decided that. And when we go to our T-interval, we go to Stat, we go over to Tests, and then we're going to scroll all the way down, and it's number 8, the T-interval. You'll notice at the top here, it gives you a choice between entering a list of data or entering statistics. So if you look at that notes sheet, did they give us a list of data? No. So we're going to move it over to Stats, and then you want to hit Enter to lock it in. It's going to prompt you in the screen what to enter. And the first thing it asks for is X bar, which is the mean. So it told us that the mean was 37.1 years. The standard deviation is 12 years. The sample size is 150 drivers, so pretty large sample size. And then we're going to put our confidence level in here, which is 99%. So now we're ready to get our interval. And I just want to warn you, if you have a TI-83, sometimes this one takes a few minutes to process. And what you'll see, they call it the worm. You'll see this little line kind of processing over here. So just give it a chance. Sometimes the T intervals take a little longer. Here's our interval. So that's our answer. So our interval is from 34.543 years to 39.657 years. Just to remind you, we were talking about a confidence interval of the mean age. So you can leave your result like this, or we're talking about the population mean, the mean age being between 39.657 and 34.543. Okay. Remember, this is representing the mean age of motorcyclists. You don't have to write that in. I'm just doing it because it's notes. Killed in accidents. No, it's not the most, it's not the easiest topic to talk about. Okay. So we have our interval. I'm going to go back to the notes sheet, and then we're going to talk about putting that interval down and what does that interval mean. So we found our interval, and our interval was this 34.543 and 39.657. And again, you can leave it as an interval, or you can write it with the population mean in the middle. And we, again, said this is representing the mean age. Okay, so the mean age is between 34.5 and 39.6. Okay, so here's what the question says. If the confidence interval limits do not include ages below 20, does it mean that motorcyclists under the age of 20 rarely die in crashes? Okay. If we look at this interval goes from 34 to 39. 20 is a lot lower. 20 is not in the interval. Does that mean that motorcyclists under the age of 20 rarely die in crashes? Let's look at it this way. What about 50 years old? A lot of people my age, I know they get their Harleys. They wait, they get close to retirement, middle age, midlife crisis. Does that mean they rarely die in motorcycle crashes? Here's what I want you to think about. This is the mean age. Because that's the mean age, the higher numbers and the lower numbers, the higher ages and the younger ages are averaging out. Think about if I take 20 and 50 and average them. I'm going to get 35, right? 20 plus 50 is 70, divided by 2 is 35. Oh, hey, that's in our interval. So when we answer it, does it mean that that motorcyclists under the age of 20 rarely die in crashes? I think your common sense tells you no. The reason, though, is because mu represents the mean age, the average age. That's why. I'm just going to give myself a little more room here. This is giving you an average age, not an individual age, okay? Even if you wanted, you could say low and high ages average out, or average to middle, okay? And this conclusion is important. Figuring out the interval is one thing. What does that mean is what's important. So we're doing the number crunching, but then we're applying it to a context. And you have to interpret what you found and understand what it's telling you. Okay, next example. In a sample of 7 cars, each car was tested for nitrogen oxide emissions in grams per mile, and the following results were obtained. So we have a list of data in this one. when we do our interval, we're going to have to choose data. Assuming that the sample is representative of cars in use, here's the instructions. Construct a 98% confidence interval estimate of the mean, oops, I don't need all that, of the mean amount of nitrogen oxide emissions. So again, we're working with a mean. And right now you may feel like, why is she making such a big deal of this? We know this is section 8.2. We know all of these are going to be means. Yes. But when you take your test or when you're doing this in your job, you're going to have to be able to choose the right type of interval. And you're going to need to be able to distinguish, is it a proportion? Is it a mean? If it's a mean, which it is, we're going to do that T-interval. And because this is the first one with data, I want to show you how to do it on the calculator. So I'm going to need to switch over real fast. You are going to want to enter those data values in one of the lists of your calculator. So anytime you have a list of data, you're going to have to enter it in your calculator. So let me go back to the calculator. So we're back to the calculator, and what I want to do here is enter that data in list 1 in the calculator. So I'm going to go to stat. I'm editing. Drag this out of the way a little bit. And when I'm editing, I'm going to move over to the top of one of the columns. I'm going to clear that out. And actually, I'm going to clear out all of them. You don't have to, but I kind of like it a little neater. Okay, so we're going to enter those 7 cars. 0, 6, 0.11, 0.16, 0.15, 0.14, 0.08, and 0.15. And again, just like when we worked with this, we haven't put data in our calculator since chapters 1 and 2. Make sure it's in correctly. And now, when we go to do this test, we said we were doing a T-interval. So we're going to go to stat. We're going to go over to tests, and we're going to go down to T-interval. You'll see there's a T-test up here. We're going to use that in chapter 9. We're doing intervals right now. And this time, we're not talking about statistics. We have a list of data. So highlight data, enter. That locks it in. List here, you need to tell it where you put the data. Our data, or my data, is in list 1. Yours is probably also in list 1. Whatever list you need, you put there. Frequency is always 1. And let me write that down because that'll help you remember it. Once you change it to 1, it'll probably stay 1, so you won't have to adjust it again. Confidence level, we were doing, what, 98%, which is kind of different, but that's okay. We have a calculator. It'll figure it out, and then we're going to hit calculate. Okay, so our confidence interval is 0.07521 and 0.16765. Now remember, this is representing a mean. I've had students sometimes see that decimal and change it to a percentage. This is representing the mean of the nitrogen oxide emissions in grams per mile. So sometimes it's a good idea to put the fact that it's a mean in there because you might be less likely to misinterpret it. And this is the average nitrogen oxide emissions. You don't have to write the words there. I'm just doing that to help you see. They range from this 0.07521 to 0.1675. 0.16765. And we, again, are 98% confident that the interval from this number to this number contains the true population mean. So it doesn't mean for sure it does, but if we have 98% in the middle, there's 1% over here and 1% over here. So we're pretty confident that we've got the right result. So now we're going to look at the question. And I'm going to go back over to the thing. So bear with me. Hang on. Grab that. There we go. All right, so we're back to our problem. And in our T-interval, we came up with this confidence interval, 0.7521 and 0.16765. And again, you can leave it like that, or you can put the mean in the middle. You don't have to do both. What you'll notice on your online work is it will, some of them will ask for it in interval form, and some of it will ask for it in inequality form. So now we need to answer the question. And the question says, if the EPA requires that the nitrogen oxide emissions are less than 0.165, can we safely conclude that this requirement is being met? Okay, so we're going to look over here. And we're going to say, okay, let's look at where that 0.165 would be. This is 0.167. So the 0.165 is in that interval. But we got to think about it. It's saying the average is going to be from 0.07521 to 0.16765. Well, if this is the highest it's supposed to be, some of those numbers are too high, right? So here I would say no. The interval, and it's a mean also, is higher, or includes values higher than, that sounds better. Includes values above 165. Okay. Can we safely say no? We can't. Okay. Next example. I'm not going to switch over to the calculator on this one. This one says a random sample of 15 movie patrons results in a mean IQ score of 103 and a standard deviation of 14.7. The 15 scores appear to come from a normally distributed population. And the reason they tell you that is our requirement said either you had to have a large sample, greater than 30, or it had to come from a normally distributed population. And that is your central limit there. Construct a 95% confidence interval estimate of the mean IQ. And I want blue. For all IQ patrons. And then we have a question. So we're gonna get the interval first, and then we're gonna answer the question. So we're doing a confidence interval for a mean. So we know this is a T-interval. If you're someone that likes to write down a little bit more, you can either highlight or you can write down, okay, we know the number of movie patrons is 15. We know the mean IQ score is 103. And we know the standard deviation is 14.7. And we're doing a 95% confidence interval. So it's just up to you. Some of you like to write more, and I probably fall into that category. Some of you like to write less. I need to see the T-interval That's your work, so I know where the numbers came from. And then you're going to go to your calculator. I'm grabbing mine right now. And you're going to go down to your T interval, which is number 8. This time we were not given a list of data, so you want to highlight stats. The mean is 103. The standard deviation's 14.7. The sample size is 15. The confidence level is 95. And we're going to calculate. And we're going to get 94.859 and 111.14. This would be adequate. You could stop there and then answer the question, or if you want to write your interval using a mu, and again, this is the average. Actually, let's put mean. This is the mean IQ for the population. So now we have to answer our question. Can we safely say that movie patrons have a mean IQ score above 100? So we're going to look at this interval. A 100 is in the interval. Some of the values are higher than 100, but some of the values are lower than 100. And they asked us about the mean IQ score. They weren't talking about an individual IQ score. They're saying the average. So can we safely say the average is above 100? No, because some of these values are below 100. So no, the mean can be below 100. Okay, we've got those values from 94.859 to 100. Now, we're 95% confident that this would happen. So let's say you had an interval that went from like 101.3 to 111.14. Then if we looked at the 100, we could say, yeah, we're pretty sure, we're 95% confident that the mean is going to be above 100, because 100, I should write it over here. 100's over here. This interval, all of the values are above 100. So you have to do a little thinking with these. And that part tends to be the part that sometimes students have a hard time with. So typically what you'll see on these problems on your test is in part A, I'll have you construct the confidence interval. And then in part B, I'll ask you the question. And the interpretation is important. I mean, that's why we're doing this, to figure out what's going on in the context of the problem.